everyone, and welcome to this video in which we'll be discussing all about pandas. And yes, this is pandas. This is not panda from China, the one in black and white, right? It's not about that animal. In this particular one, we'll be talking all about pandas, that how in Python we can leverage a tabular data manipulation techniques. And my name is Anirudh. I am founder and director at Fireblaze AI School, and I'll be teaching you all about this, whatever we have discussed until now. Right? Now, let's not invest a lot of time and directly jump on to how to do it, because I want to keep this particular one hands-on. And just a quick bottom lines about this video, that you need to know or have knowledge about Python as well as NumPy to learn more about pandas. So in my previous videos, which you can see below, we have already explored introduction to Python. We have already explored introduction to NumPy. Python was a core programming language, and within that there was a library called as NumPy, which was used for numerical Python. And now we'll be dealing with the tabular data manipulation techniques, that how tabular data could be worked out. And for that, exclusively in Python, we have something called as pandas. Now, as we have already seen a lot of data structures, right? We have seen we have seen strings, integer, floats, boolean. Then after that, we have seen some data structures such as list, tuple, dictionary, set, right? And then in NumPy, there was a hybrid data structure which was called as NumPy n-dimensional array. Similarly, moving ahead, in pandas, we have two core data structures which would be used a lot. And these two data structures are called as series, and the other one is called as a data frame. Now, when we say series and data frame, we don't actually get any idea about what it would be, right? Now, until now, the story, it's like we were successfully able to get the data in Python in tabular form, but it was in an array. And the limitation of NumPy array was that it will just have 0, 1, 2, 3, 4, 0, 1, 2, 3, 4 indexes. So there won't be efficient data selection techniques apart from 0, 1, 2, 3, 4. So it's only indexes. You cannot have your own references. Secondly, your entire array will be of one data type. So you again don't have a lot of options over there to have multiple different data types and perform all different kind of arithmetic operations over there, right? For each column. So that's why, to cover up that kind of limitation over here, we have this series and data frame, wherein the actual data, how in real world we work, right? Like, though it be any domain, it be healthcare, it be pharma, it be manufacturing units, it be textile, any kind of domain, right? Financial as well, why not to forget that. So your data is in tabular form, and you generally use CSV files or Excel sheets, tabular data, to handle them, right? Now, to read your data from Excel sheet, to read your data from CSV sheets, that data would be coming up in pandas format in Python. So that's why pandas is very important library in terms of data science, data analysis, or machine learning and AI. Okay, so that's why pay attention to this particular one a lot. And again, the prerequisites for this video is Python and NumPy. Now, moving ahead, as we have already seen how do we load libraries, right? Here also, pandas library is being loaded as something called as PD. So PD is an alias name given to pandas while working in the environment. Now, I have already created a notebook called as all about pandas, and in this I'll be importing my pandas library. Now, to work with pandas, I'll also have to work with NumPy. So I'll write import NumPy as NP, and then I'll also keep import pandas as PD. So these two libraries, what I'll do is I'll keep them handy in my notebook so that I can use both of them inline and then work out my processes. Okay. Now what I'll be doing is I'll be writing, say, first we'll be understanding what series is. Okay. So series is one of the data structures in Pandas which is used for tabular data manipulation. Now the core thing what you need to understand about series is that series has only one column. So series will have only one column with index or label, and there would also be values in the form of an array. Okay, values will be in the form of an array. So if you look at it, now it would be a tabular structure. Like imagine it to be something like a 1D array. Okay, a 1D array is just 0, 1, 2, 3, 4 and some numbers. Now they are horizontal. It is displayed as a horizontal one, right? Now whenever we say that we want to have it in a tabular form, it needs to be vertical. So different rows could be there and different column could be there. But this guy series will have only one column. So one column, one vertical column would be there, and there won't be another inline columns to it. Okay, that is a part of data frame then. So now over here it will simply just have one column, and each row will have different values. So it's not 2D, it's just one dimensional array in the backend. Okay, so I'll try to make one series. Now series is a hybrid data structure present in Pandas. Okay, and it will make use of all the existing data structures like list, tuple, array. You can use all of them, even dictionary. You can use all of them to create a series. Let's check it out. So if I write series 1 is equals to a series, and if in round bracket I pass a list, say 10, 20, 30, 40 and 50, and try to run it. Okay, and now over here it's throwing me an error. Now why is it so? It's saying name series is not defined, because series is not a part of Python. It is a part of Pandas library within Python. So you'll have to import that series, or you'll have to write prefix as pd. So I'll have to write pd.series, then it will work. Or what I can do is I can import the function and keep it. So I can even write from Pandas import series. So when I run this, and then later on if I try to run the code again, right, if I try to run this code again, and now if I don't write pd, it will run smoothly without an error, right? So series SCR1 we have 10, 20, 30, 40, 50, and if I try to show you SCR1, can you see you are getting one vertical column over there with 0, 1, 2, 3, 4. So those are the default indexes which are displayed over here unlike array, and you are having your values is 10, 20, 30, 40, 50. And then there's this N64 which is coming, so don't worry about that. It depends on what way in which it is storing. So it can be like, it can store in 32-bit format, 64-bit format. So it depends on which operating system and which bit you are using. So, but primarily with respect to DS applications, don't worry about that. Yeah, like you'll get in 32, in 64, float 32, float 64, U1, U6, U7. These are all different data types. Basically, it's just int. Okay. Now, in the back end, the data of this series guy is stored as an array. The values are stored as an array. And the indexes are just 0, 1, 2, 3, 4, a sequence, a range. The beauty about series is that this series can be renamed. You can have an index label. You can have a label over there of your choice, which would be a reference to the value. So if you give SCR1, and if you write, say SCR1.index is equals to, or say just index, you'll see a range starting from 0 to 5, right? If you write SCR1.values, you'll get an array of all the values. So dot index is used to get all the indexes, dot values is used to get all the values in the form of an array. Now over here, similarly, you can even write SCR1 is equals to, so what I'll do is I'll just copy paste this, and I'll give a comma, and after a comma I can simply write index is equals to, and I can pass A, B, C, D and E. right? I need to pass it as a list. Okay, so we need to pass it as a list. So the C code should be closed. So now you can see you are having 5 different values over there. And if I run it and if I show you my SCR1 now, you can see you are having A, B, C, D, E as indexes and 10, 20, 30, 40 and 50 as values. So we have given our own indexes to the data. So first one is A, then B, then C, then whatever you are giving in whatever order. You can even pass this guy as a dictionary. Okay, and you can like the entire key value pair would be your indexes and values would be your values. Okay, so if you try to run this out, and this guy could also be a tuple. So you can as well give a tuple over there like this, run it, try to see SCR1, again same thing. Okay, now I'll show you one more. Say SCR2 is equals to say series. Now I'm passing a dictionary A and value as 100, B and value as 200, C and value as 300. And when we run our SCR2, can you see that your keys are actually getting converted as indexes and values are actually converted as values of that particular series, right? And now if to this SCR2 you write index, you'll get ABC. If you write SCR2.values, you'll get 100, 200, 300. Alright, so that's how a series works. Now in any kind of data structure, whenever you have, right, and you try to pick it up, you'll be getting it as a single column is always a series. Okay. Now what I'll do is, these are the two techniques and this is how you can create different series. Now I'll show you a quick demonstration on how data frame is. Like data frame, I told you, is a collection of multiple series. So first, to make use of a data frame, we need to import that guy, right? We need to have that function in our environment to work with it. So for that, what I'll do is I'll simply write from pandas import data frame. Okay, so data frame is there. Now within this, what I can do is I can simply write df1 is equals to a data frame. Within that, I can pass np.arange, starting from 1 to 26, and then we can simply reshape it to 5, 5. df1. So can you see, we right now are having a data frame which is of 5 rows, 5 columns, and the data is actually coming from a numpy array. So this was actually nothing but a numpy array, and this numpy array is now being picked up and created as a data frame. So that's why the default indexes in the data frame as well are 0, 1, 2, 3, 4 from top to bottom and 0, 1, 2, 3, 4 from left to right. Okay. Now within this as well, the beauty is that you have a provision to select indexes and column, and you can also give your own indexes and column names over here, right? So if I try to simply write df1, I'll try to pass it again. Okay, so if I try to simply write, and if I try to give a comma over here, and if I write index is equals to say quotes A, or say maybe this time I'll pass a list A, B, C, D, E. So if I run it, can you see that it is giving me A, B, C, D and E? Now this list A, B, C, D, E quotes will separate out and give me quotes A, quotes B, quotes C, quotes D. So like don't get confused with this particular part as well. Okay, so if I just show you, it's equivalent to pass this over here instead of this. Okay, so it's one and the same thing. Now you can see the indexes are there. Now if you want columns as well, right, after the comma I'm hitting enter so that it comes in the next line, and if I write columns is equals to call 1, call 2, call 3, call 4 and call 5. And if we run this, if I show you df1, can you see you are having column 1, 2, 3, 4, 5, and then you are having different rows. So basically we have given our own column names over there, right? We have passed our own column names as well as index names, and the data is 2. And the shortcut to access this would be df1.index. You'll get all the indexes. df1.columns will give you all the columns. df1 dot values will give you all the values in the form of an array, right? So the data frame has all of it. Now, this is how you actually can create a data frame and a series. Now, I'll tell you one more way in which a data frame could be made, but this time I'll tell you with respect to a dictionary, right? We'll be using a dictionary to create this data frame. So now in this, what happens if we say pass df2 is equals to data frame, okay, and within this if I write say name, and within name I am passing a list of names. So say I'm writing Ajay, I'm writing Ravi, I'm writing say Prabhat, I'm writing say Prashant, and these are the four names what we have, right? Now maybe the name value I can write it as first name, and within this what I can do is I can give a comma and I can write their city. So we'll have different rows and columns created where we actually have first name and their city associated. But the core concept that you need to remember over here is that the key is going to convert into column name, and the value of that column would be in the form of a list over here. Okay, so if I give this and write a square bracket, and for Ajay if I write Mumbai, for Ravi maybe I write New York, okay, and then for Prabhat I write say Pune, and then for Prashant I write Nagpur. And when I run it, can you see my df2? Can you see my new data frame being created where first name is my first name of the different entities, and the city is having different values, and they are getting matched. So Ajay is from Mumbai, Prashant is from Nagpur, Prabhat is from Pune, right? You can add multiple columns over here as well. There are different ways to do that, but yeah, there are different ways to perform arithmetic operations, do all lot of different things in it, right? But I hope right now within Pandas this is clear to everyone that how we can create series and a data frame using different techniques in Pandas within NumPy, right? Now to do all of this, right, again I am telling you there are different videos. There are a lot of videos which would be coming up on this YouTube channel as well, right? But I need to know how you are understanding and how and what topic specifically you want to learn more, right? I had a huge response on these different topics coming in from a lot of time. That's why I am creating this exclusive video on Pandas where I'll be teaching everything. And if there's some new topic which you want to learn, please write in the comments below. Or even if you want some improvements in this particular series and data frames topic, please let me know in the comments. I'll try to cover it out in the coming videos. All right, now let's get back to work, and now let's try to understand that how basically we can select some entries from this series and data frame, because once we know how to create it, right, we'll not be creating it every time, because a lot of times data is already collected and you just need to work on it. So how do we work it? We should know how we can select some entries from a series or a data frame. So let's try to emphasize on that. Now what I'll do is I'll quickly give a heading as selecting entries in a series and data frame. Now within this we already have this S1, right? What's the name of my notebook? What I'll do is I'll just quickly run all of my cells, and SCR1 was the series which we defined for the very first time with A, B, C, D, E and 10, 20, 30. So let me just have that one back. So when I'm writing SCR1, I'm getting this series, right, with A, 10, B, 20, C, 30, D, 40 and E50. Now within this we already have labels, that is A, B, C, D, E. It's no more default indexes which were already given as 0, 1, 2, 3, 4, top to bottom, right? But we do have privilege to access them. So even if we write SCR1 square bracket 0, run it, we can fetch the 0th index unless and until the new indexes are in numbers again. Mine are categorical, right? So I can fetch them out. Then, so this I have exclusively given a name to this method. I say this as grab by default index. Then secondly, I do have a technique in which I can even apply slicing technique to this. So 1:3 will start from 1 and go till 2. So we'll get B and C. And if we run this, you can see you got B and C part of the series. But it is on the basis of 0, 1, 2, 3, 4, the default indexing. Slicing on the basis of a range, default range. So I call this method as grab by range of default index. So the name specifies exactly what these guys do. Okay. Then if I again write SCR1 square bracket A, obviously I'll get the value of A. Okay, and this is the very basic one wherein you are just grabbing by the index label. Whatever were the labels, you are just fetching that by the name. Okay. Similarly, you do have a method in which you can fetch multiple labels in one go. But for that, you cannot just simply pass a label name. You have to pass a list of labels. So you need to again give a square bracket. So you need to write SCR1 square bracket, again a square bracket, A, D, and say E I want. And this one would be grab by multiple labels. Okay, run it. You'll get ADE and 10, 40, 50. Okay, are you getting it? So these are the 4 different techniques, and now the most powerful one. So SER1, which is already there with A to E and 10 to 50, within this we need to have, say, SER1. And now suppose we want to give some condition on values. We want to see with respect to values how we will be able to fetch the data. So for that, what we can do is we can just simply give a boolean over there. So say SCR1 less than 25. What do we get? We get the entire series converted into boolean. So A, B, C, D, E, and wherever the value is less than 25, there you get true. And wherever it is greater than 25, there you get false. Now, what if you want to select the ones which are true? For that, you need to just take this guy and pass it in SCR1 square bracket, SCR1 less than 25. Run it, you'll be able to fetch only the ones which are less than 25. And that's how you can simply select entry or grab an entry. Now there are more complex ways in which you can select your entry from a series, and like you can use your logical operator to give multiple conditions. All those parts are in the advanced ones, right? In the coming videos we can have them, but these are the basic techniques of selection in a series, and this one I exclusively call it as grab by logic over values. Okay, I hope that these basic techniques for selecting entries in a series are pretty much clear to everyone. Now moving ahead, df1, if I have this, that was my data frame. Now let's try to understand how we can select an entry from a data frame. So within a data frame, there is a default technique using which you can fetch some entry. And to do that, you can simply write df1 square bracket col1. And this is just simply grab by column. Now in a data frame, the priority is always given to the column. So directly if you want to fetch something, you need to write it by column name. It's nowhere rows accessible. For that you need to have a different method. You do have that possibility, but not in the default technique. In the default, it's always column wise. And when we write directly the column name, it gives us the column in the form of a series. So you can see it's coming as A, B, C, D, E, that are the indexes, row indexes, and the values of that column. and this one would simply be called as grab by column name. Similarly, you can even have multiple columns, but again, whenever the word multiple comes, you need to have it as a list. So one more square bracket, call 1, and I need to have call 3. Run it. You can see you have call 1, call 3, A to E, and all the values within it. Now you are trying to access 2 columns. Obviously for 2 columns it would be a data frame. So this one would be called as grab by column name. So when you run it, you'll get all of it. Okay. Now within this as well, there is a technique in which you can slice your entries out with respect to rows. There is no way that you can fetch directly with respect to rows in default techniques. So if I just simply try to write df1 square bracket 0, you'll not be able to access it. It will give you a key error. Means 0 is not a label in any of the sites, or basically it will check columns. So key error 0. Okay. So that's why you can, but you can give slicing over there. So if I write 1:4, it will start from the first row and go till 4 minus 1, that is the third index. So if you run this, and you see it is starting from B, that is A is skipped because A was 0. And then you are getting 1, 2, 3, that is B, C, D. Okay. So this is called as grab by range of index. Okay. Now these are the 4 different techniques, and one, the exclusive and the very important one. Now suppose there is a huge data. Okay, there is a huge data, and then from that huge data you want to say select some entry on the basis of a particular column. Like say for example, there is age column, and there are a lot of other entries and columns in the data set. You want to see only the data of people who are having age less than 18. So you want to give a condition only on a certain column, right? You want to give condition only on a certain column. Or say maybe there is a column called as gender, and within gender there is say 2 genders available right now as male and female, and you want to fetch only of female, right? And then all the entries. So for that as well, there's a method wherein you have the privilege to give or filter on the basis of a certain column, and that can be done as df1 square bracket, say call 1. Now you can see call 1 entries over here, right? 1, 6, 11, 16, 21. Now I want to give a condition on this column. So this will give me a series of that column. Now on this, if I simply write say less than 10, I'll get true and false. So 1 and 6 are less than 10, so I'll get true and false over there. And then within that, if I want to fetch this, I'll just simply write df1 square bracket pass this, but it will give me data of entire row, but the selection is done on the basis of column 1. So you can see wherever the values of column 1 are less than 10, that only is being judged, and then the entire data is being given, all the columns for those rows are being displayed. Okay. And this one is my favorite because it's a lot. I mean, the use cases of this are a lot, and this is called as grab by logic over a column. Okay, and with this we complete our data selection techniques. Now obviously there are a lot of different techniques to select the data in data frame as well. So at an advanced level, I'll give you a hint. There is a function called as ilock and lock, which would again be used for the basis of index location and label location entries. You can explore these topics, or if you want to dive in, you can also check out one of our courses on Fireblaze Academy. So the link is given below. You can get certified, you can do the course, you can solve some questions, you can give answers to the quiz, and then you can have your own certification in data science, right? So do check that website out if you found this video useful. This is Anirudh Kalpande, founder and CEO at Fireblaze AI School. I hope that you liked this particular one, and stay tuned for the next one. Please do like, share and subscribe.